Hello everyone, welcome back to another video. What we're going to be looking at today is the derivatives of trig functions. So derivatives of sine, cos and tan basically. So we're going to have a look at that. So let's just get straight into it. I'm not going to get into the proofs of where these things come from. I'll leave that for class, but let's have a look at them. So the derivative of sine x is equal to cos x. Okay, so sine just becomes cos. Which is an easy one to remember. That's your sort of basic one that's really easy to remember. Sine becomes cos. Because of that, a lot of students go, well, does that mean the derivative of cos is sine? It's actually not. It's actually negative sine, okay? So the derivative of cos x is negative sine x. That's a little bit harder to remember. Students always forget that one, so just be careful of that one. I'll tell you a way that I remember that in a second. And finally, the derivative of tan x is sec squared x. Now, if you haven't seen sec before, that's okay. What that's equal to is that's 1 over cos squared x. Okay, so that's a bit of a tricky one, but you will see that every now and then. So the derivative of tan is sec squared, okay, which is 1 over cos squared. So that's that. Now, if you have a function inside of sine x, so if you've got like a number in there or something else, if it's not just plain old sine x, if it's sine of, x squared plus 1 or something like that, then the chain rule gets applied here. And so the derivative of that is equal to cos of g of x. So sine goes to cos, right? The inside stays the same, and that gets multiplied by the derivative of the inside. So multiplied by g dashed of x. The derivative of the inside gets multiplied at the end. Okay. Same thing applies for cos of g of x. If you've got a function on the inside of that goes to negative sine inside that function on the inside, that g of x stays the same on the inside, and that gets multiplied by the derivative of that inside function. Okay, hopefully that makes sense. When I do an example in a second, that will make more sense. And the derivative of tan is sec squared, but if you've got a function on the inside, again, it's 1 over, I'll do it over here, just so it's 1 over cos squared g of x, right? So that's that. Like we said before, the g of x sort of just stays inside, and then that gets multiplied by the derivative of that inside function. Okay, so what it ends up actually being is, and I'll just put it here, is just g dash of x over cos squared g of x. Okay, hopefully that makes sense. We'll have a better look at what's going on in the example, but they're sort of the ones you need to remember. Just a note before you're going on, what's happening here is that this is what's called the chain rule. So whenever you've got a function on the inside, shouldn't have highlighted those. Whenever you've got a function on the inside of another function, and what happens is that we differentiate the outside, so sine goes to cos goes to negative sine, etc., and we leave the inside, we leave that g of x as it is on the inside, and then we multiply it by the derivative at the end. So this is called the chain rule. That's getting multiplied by that derivative, and the inside stays the same. Hopefully that makes sense, but we'll go and do some examples to make sure it makes sense. So let's have a look at this. Let's have a look at it. Differentiate y equals cos of 7x. Okay, so for part A, the derivative dy dx is equal to cos goes to negative sine. And I said I was going to remind you, this is how I remember it, is dc negative. Okay, so that's the sort of thing I remember, is dc negative. And what that means is that when you integrate sine, we haven't talked about integrating yet, or differentiate cos, then you get a negative result. Okay, so here we are differentiating cos, so dc, so this is going to be the negative response. So that's how I remember that cos goes to negative sine. So this is going to be equal to negative sine 7x. Now, on the inside, that 7x, you've got like a function there, 7x. What's the derivative of 7x? We need to multiply it by the derivative of 7x, which is just 7. Okay, so my derivative is negative 7 sine 7x. That's my answer there. That's the derivative of that function. Let's have a look at another. We've got f of x is equal to sine x over 4 plus 19. So we're going to go to f dash of x. It's a different notation, but it means the same thing. Sine goes to cos. So it's going to be cos. The inside stays the same, x over 4. And then we're going to multiply that by the derivative of the inside. And remember, x over 4, that is 1/4 x. Okay? And so what's the derivative of 1/4 x? The derivative of 1/4 x is just 1/4. Okay, so it's going to be cos x over 4 times by 1/4. That's that first part of it. So that's the derivative of that part done. And what's the derivative of 19? The derivative of any constant whole number is, or any number, I didn't mean to say whole there, is just equal to 0. And so the derivative, nothing happens there. It's just the derivative is just equal to 0. And so my final answer is 1/4 cos x over 4. Okay, so that's my final answer, the derivative of x. Last one, let's do a tan one here. And so we've got y is equal to tan negative 3x. So let's do dy dx is equal to, so we've got tan. Tan goes to sec squared, right? So sec squared. We leave the inside exactly how it is, negative 3x, and then we multiply that by the derivative of that inside part. What's the derivative of negative 3x? Negative 3. Okay, so that's the derivative of that first chunk. That's the derivative of that. Let's keep going. The derivative of the second part, cos, goes to negative sine. So I'll just put some brackets here so that I do that. So plus negative sine. So cos becomes negative sine because remember, is DC negative? When you differentiate cos, it becomes negative sine. We leave the inside the same, 2x cubed plus 3. That just sits there by itself. And then that gets multiplied by the derivative of the inside. So what's the derivative of 2x cubed plus 3? 2x cubed, the derivative of that is 6x squared. And the derivative of 3 is 0, so that just sits there. So that's everything there. And so that's the derivative. All we just need to do is just clean it up a little bit. So that's negative 3 sec squared negative 3x. And then here we're going to get minus, because of that negative out the front, minus 6x squared. We'll just bring this function out the front. Sine 2x cubed plus 3. And that is it. That's the derivative. Can't do much to simplify that. There's a couple of things we could do, but there's no need to. That's my derivative of that function. Hope that makes sense. That's how you differentiate trig functions. See you in the next video.